Hi, Danijela Horak. Welcome to the podcast and the show. Thank you for joining us today.
Thank you, Chris. Pleasure to be here.
Great. Well, yeah, let's just jump into it. I think excited for the show. It's going to be a mix of kind of your career as usual, what you've done up to the BBC. I think you've had a nice mix of industries as well, and it'd be great to go over some of the common themes that you've seen in machine learning. And I think you have a PhD in mathematics, and I'm sure that's provided a unique approach to machine learning to you over the years. And you've done some really interesting stuff around deepfakes and responsible AI. So go through that today. Um, so yeah, would you just like to start, Daniela, about talking people through your career and how you got to the BBC and what led you there?
Yeah, well, to be honest, my career has been very random. And for the longest time, I actually thought that that is kind of what it is supposed to be. Although very occasionally, basically, you would hear about really extraordinary people who've, dedicated themselves to kind of one line of inquiry. Like, for example, Terence Tao, who started, doing math. Obviously, he was a math prodigy as well, but he also started very early. Or in sports, it's like a common denominator where like they all start very early and they all kind of stick to it. And but like in our world, in the world of the information workers, it's very common to think that some kind of Brownian motion is okay and is expected and almost kind of um, looked very positively upon. And I think, until and I believe the same really. And my journey has been like super random. But, but since I've started reading the book by Richard Humming, which is called The Art of Science Engineering, and engineering, he's basically there really laying out a mathematical proof why kind of basing your career on the Brownian motion is like the worst possible thing you can do. So he's done like a little proof there on like if you have a stochastic random walk, your expected distance from the origin after n steps is going to be like of the order of magnitude of square root of n. Whereas like if you had a tractor, which is like can be basically compared with some sort of vision or something like that, you would your approximate distance from the origin is going to be O of n. So like it, the half of order of magnitude more, and even mathematically, it's so obvious that jumping from one thing to another is like not the best strategy, and choosing being led by your interest and kind of sticking with it for much longer seems to kind of reap a lot of bigger returns than I think what people usually do. So, going back to your original question, I did a PhD in pure maths, then I've done two postdocs in kind of more applied side of maths, and then I've switched to industry to do some ML first, like a startup, and then the BBC.
Nice. And yeah, you kind of touched on it there, the industries that you worked in, obviously media, the BBC Finance, and
Mm.
then I think synthetic biology during your postdoc. Um,
Yeah.
are there any common themes in machine learning or mathematics that you see running through that have helped you lay solid foundation? Because I think you've had a great career so far. So, what are the kind of things that you've seen that have helped that may be unique to the industry or themes that are running through?
Well, yes, I think I've been like super fortunate to have studied math, like at the time when I studied it, and simply because like you see that the number of scientific papers in AI and ML doubles every year almost now, and now even like the progress of pace, the pace of progress is like even faster. So which means, like for us in the field, that for example, what is going to be relevant this year, like is like half of that we don't know and we have to kind of pick up and read and study. And half of what's been kind of relevant last year is gonna probably become irrelevant. And if you kind of um, expand this kind of time window, let's say like in 2010, I was just kind of checking before this podcast. It was like apparently per year in all the fields, AI, computer science, and machine learning, there were like around 4,000 papers. And in 2024, there are like 50,000 or upwards. Like it's incredible how much the field has changed. So the only basically currency you have as a researcher is your ability to solve problems and to learn quickly and to adapt quickly. And this is something I think I've kind of mastered doing math. And also on top of that, like I think what really helps is understanding fundamentals well, because like a lot of machine learning at today, and a lot of these publications are almost kind of consequences of this kind of a couple of main fundamental principles. So if you basically do understand basics really, really, really well, fundamentals, then it's easier to build on top of that. So like organizing your internal knowledge in a almost kind of hierarchical way and allowing yourselves to integrate new knowledge upon that kind of structure you already have is probably what can be like super beneficial. And that's what the common themes are basically. It's always difficult, especially like in school. You don't or at the university, no one teaches you how to solve problem, especially not in a business setting. Like they give you algorithms, theorems, whatnot, and then you're kind of the search space is much narrower in these settings. And then you're faced, you come to business setting, and then you're faced with all of this kind of real world ambiguity, right? So what do you do then? And I think this is where like a structured scientific thinking helps a lot. In a way, like your discipline, how you approach the problem, how you frame it, how you basically set up your hypothesis. A lot of people like just jump into the problem, especially the junior ones, and kind of throw a specific model at it without actually kind of taking a step back and saying, well, looking at my data and looking at this problem, my hypothesis is that the data is in that shape and this model is going to work like that. And I expect these results. And also like a discipline of, properly baselining, benchmarking, and so on. So like there are a lot of things that you can do with that kind of scientific mindset that can help you along the way. And the difference can be like between 3 months and 12 months. And that's the difference probably between junior and senior, because senior knows how to kind of set up a problem, knows how to set up a hypothesis, is very keen and kind of zeroing in on ablation tests. Like you need to have like a solid way to measure the effect of any changes you make to your original experimental design, be it like a addition of new features or, like conducting all sorts of experiments until you basically end up with the proper solution.
Nice. And super interesting. I think coming from pure mathematics background is obviously highly beneficial for machine learning, but I think other people might choose computer science or one of the other popular courses in university. Do you think that having that mathematics base coming into more engineering focused problems, coding, was there anything you learned? Was it a challenge picking up programming languages, for example, or did that come quite naturally?
Well, I was, I kind of graduated a very, very long time ago, but like I had specific programming courses ever since I was in high school. So it's like you don't kind of graduate maths without actually knowing how to code. At that time, when I was in school, we were like looking at C++ and so on, but that is kind of well, we've even kind of studied assembler, believe it or not. But definitely that's one aspect. That is something that tends to be challenging, and that's what the separation is between like data scientists or machine learning researchers in a way, and kind of properly formally trained engineers who are like machine learning engineers or software engineers. So there is still that chasm, and yes, and the collaboration sometimes can be can have frictions, I guess. But I believe that as long as the separation between the two kind of tasks or the ownership of the two different people in the team, it's clear. I don't think that could be an issue. But obviously, software engineering is a huge part, especially nowadays when I think when the need for formally training models is just coming to nothing. Like there are just very few places who do it nowadays, and the majority of focus is on AI engineering that involves nothing, no training at all, and it's all about like what's left from the traditional machine learning is basically evaluation and benchmarking, and everything is pretty much like engineering in a way, which is kind of sad. And it's a little bit, ironic that data scientists and machine learning scientists are basically the first one to face this kind of effect of AI. I don't think that's kind of talked about a lot, because we all hear about these people who kind of end up with $100 million contracts, but those are like 0.001 of the people who used to work on machine learning tasks. And now, everyone else has to kind of shift their domain of operation slightly and move more into engineering.
Yeah, I think that's a really interesting topic as well. You've got really intelligent PhD students coming onto the market, but it's now more competitive than ever. I think probably slightly different to when you and I came onto the market. What advice could you give to someone? How would you position against AI? I suppose it kind of comes back to being able to link the model to the business problem and that side of things. But how would you position today if you was coming onto the market?
I guess going back to these fundamentals I mentioned at the beginning, I think a lot of people compromise compromise their interests for the sake of the, let's say, financial benefit, or just finding a job and so on. It's all of ours reality, but I think there is a version of this world in which everyone is kind of more aligned with their inherent interests. I'm at the moment, the market is very dull. If you want to, this is how it feels to me. Like there are very, very few places that actually do interesting things. A lot of enterprise use cases are focused on, plugging in commercial models and building agents. And although that is, that can potentially be interesting to some people, I think there is a huge group of people that will find that kind of less appealing, because it's I think you lose a lot of agency and control in that kind of setting, and you kind of revert your work to engineering rather than kind of this messy creative process of training the models and doing more fundamental things.
What out of interest, what do you think the most interesting work in machine learning is right now to be done, in your perspective?
Well, it's always like at the frontier. That's where the most interesting work is, obviously.
Yeah.
And if you're lucky enough to end up in the big labs or even like big research institutions, that's amazing. They're also like, I really like the startup scene or scale up scene. Like they are boldly kind of taking on more kind of ambitious projects. And I think this is where the new innovation or the new breakthrough must come from. Obviously the big labs, they are all kind of going in one direction, as we see kind of scaling up and whatnot. And we see like the emergence of the new startup kind of cohort that is looking into other ways of achieving intelligence, if you will, right? And also, going back to the agents, somehow I think, like, to me, it's very, very problematic that like a large group of people today think like you can kind of prompt the model to do anything, even if you assume that it's like the most intelligent model, right? Like behind it is John von Neumann, right? Behind that model sits John von Neumann. He can do anything, extremely intelligent. And you basically give it a prompt, right? And I think this worldview where you think everything is word bound and can be kind of put into words, it's completely wrong. It's been held by the ancient Greeks, Socrates, Aristotle, and Plato. But like what is then the role of experience, right? Like you can theoretically, and that's like the difference between theory and practice, between you kind of hearing something and then updating your way. So I think this element of like, even if the model, like it's too much to expect of a model to do things without actually actively learning in a way, as human does. So I think there's like a huge disconnect there, and maybe the market will correct itself slightly right there, because at the moment everyone thinks now, oh, we can do everything with agents. Okay, up to an extent that might be true, but there's like a huge element of what you do as an organization or enterprise that requires weights update in a way, especially if there are a lot of very idiosyncratic things your organization is dealing with, which there must be, right? I do hope that the market will correct itself somewhat, and the people will realize to achieve the maximum return, they will, have to kind of shift their approach slightly. But the question is how much of excellence they will demand, and how good is good enough, I guess.
Yeah, certainly a lot of hype in the market and a lot of FOMO at the moment. So, like I say, I think there will be a market correction because certainly speaking to a lot of companies, they've invested a lot into agents and maybe not got the returns we wanted yet. And having that human in the loop and like an agent human team seems to be definitely the best way to go. In terms of AI innovation at BBC, then I know you've built a great team there. You've done some amazing work around LLMs and deepfakes, and really excited to speak to you about that today. Do you want to just introduce people to the structure and vision of your research teams and projects at BBC?
My team is around 25 people, and it's a mix of computer vision scientists, natural language processing scientists, and engineers. We have looked at a lot of modern innovations in the field and have worked on the range of projects from, image restoration, colorization, to neural radiance fields, to in computer vision as well, to face anonymization, and now finally have kind of converged to the deepfake detection and the work in that kind of space of automatic fact verification. And on the other side, on the LLM side, we've been, on the NLP side, we've been predominantly working with the large language models and try to basically see or test their limitations and see where they could be useful for the BBC in particular, and what are the maybe drawbacks of using commercial models, and how we can kind of help the BBC solve this kind of biggest issues with the commercial models. So I know a lot of people is kind of voicing this concern, but for the journalistic organization, news organization, I think it is very problematic to rely on closed source models that are aligned in a black box way, in a way, which remove a lot of agency from the user. So basically, it's increasingly, I think, predominant that the internet is seen through some sort of AI search, which inherently will impose the worldview of that model on the output. And having people in the journalistic organization who are kind of committed, especially at the BBC, who are committed to impartiality, committed to, no bias, and committed to the trustworthiness and truth is very problematic, I believe. And people, in all media organizations must be really careful with the usage of these closed tools.
Yeah, really interesting point, and probably not enough work done on it. It's all about how can we commercialize the models and make as much money from them as possible in some senses. But yeah, when I think of the BBC, I don't necessarily always think of LLMs. What are some of the real world use cases that you're using them for? And then the second question to that is, how do you handle the bias in the models?
So one of the use cases is the rewriting in the style of the BBC, because if you try to do that with commercial models, they would completely kind of go off track, and the style would be nothing like the BBC style, despite probably the fact that a lot of our training data is in these models already in their training set, because we do know that in Common Crawl, there are some of our articles that have appeared online since 2012 onwards. So the training data is de facto there, but they still cannot pick up that style, even with few-shot prompting or kind of carefully prompting how to rewrite a specific articles. So when it comes to this use case that we've worked on, it's like BBC has a service which is called the Local Democracy Reporting Service, whereby they kind of employ a lot of freelance journalists that report on the local news, and then these articles are then given to the BBC journalists, who typically would just rewrite them and publish them on our web pages. And this, because we have so many of these journalists, the volume of this article coming in is huge, and BBC can rewrite only around like 10%. And, we recently deployed that model, and there has been a press release on that one. And, the model that we fine-tuned is really much better in terms of the style markers than the out-of-the-box model. And yes, and it's also relatively cheaper to run because it's a smaller model. And yes.
Nice. Okay, cool. Well, yeah, it's super interesting stuff. And yeah, moving on to deepfakes. Again, I wouldn't necessarily associate BBC with deepfakes, and there's certainly a lot coming out now with some of the recent models released by Google, and how easy it is to create a really high quality video with next to no budget. And these are just the things that we're aware of. First of all, kind of addressing the problem. How are you kind of seeing bad actors use deepfakes, and what do you see in the market right now?
Well, I think there's always been bad actors who would kind of misinterpret or kind of present events out of context, or kind of put misinformation out there. It's only that they are now, like, tool set has expanded enormously. And obviously, these kind of sophisticated actors will kind of continue doing it. And there is no automated way to, so far, to kind of capture some of it. That does not include the human in the loop. However, we see that the domain operation increases significantly, right? Even like one of the interesting examples at the BBC is that we see like a huge increase of people kind of submitting AI generated images to weather watchers. Don't know whether you know
No,
the service.
please tell us.
So yeah, there's a service basically where you as a contributor, as a member of the audience, you can upload like your own photo that you took somewhere in England with the specific weather conditions. And if your one is chosen, you get a mention, right? And we see a huge increase of people just kind of generating random, nature photos with specific weather and claiming it, somewhere in England, and so on and so on. So that's one use case. That's like one obvious, I would say, kind of less harmful way, or like a less harmful use case for these deep fakes. But I guess, there are like many other more dire situations in which having a robust deepfake detector is necessary.
Yeah, and I guess the actual deepfake project that you led, how can you spot a deepfake?
So we, our computer vision team, led by Jules Sock, and have a couple of super talented computer vision scientists working on that problem. I need to mention them: Woody Bayliss and Mark Goretz. They've built this kind of classification model on the proprietary data set. So we kind of, first of all, like, to build any model, you have to have a data set that reflect in a way what you will see at test time. So when we started, such data set hasn't existed. So that was the first step, basically, to create a data set. And then we've experimented with multitudes of different models. Obviously, when you're building any classifier, you have to have a feature extraction method and then the classifier bit. So we've experimented with many different architectures. on that data set that we've created and come up with a solution that is on par or beats most of the commercial models on all of to date available deepfake generators. Now, for that model to be fit for use in the newsroom, like you can't just deploy it like that and and give it to the journalist and say this image is 0.6% with the probability of 60% fake or this because like they can't really deal in these uncertainties. And to make matters worse, the models, even if they are like super accurate on your test set or validation set, in the in production situation, you may end up with like out of distribution examples that model typically mishandles or gives like a super high confidence, like it's super overconfident in the wrong predictions. And I think a bulk of our work has been in kind of developing methodology to increase trust in these models. And this kind of breaks down in two things, which is one is uncertainty quantification of these models, kind of building the models that know when they don't know in a way, and saying, no, I can't tell you this in a way. And then the second bit is about the interpretability, like making sure that you explain the decision making of the model, how it came with a specific decision, and then make that available to the journalist. Now, I think that line of inquiry is kind of becoming increasingly difficult because, unlike with the traditional image classification, where your, features are like you can see them, they are like visual, semantically available even to a human. When it comes to the deepfake detection, usually the signals that lead to classification that something is fake, something is real, are more subtle, and they are not available to you to see via the naked eye. It can just be like a specific noise pattern or so on. So this is still a very much an open problem on which we're collaborating with Philip Torr's group at the University of Oxford. And it's also in the field a very active area of research. But I think, the market is at the moment underserved for this specific use case. It's underserved in terms of having deepfake detection models that journalists or media organizations can trust. And because it's like a high risk use case, almost like medicine. I don't want to kind of put it out there, but it is indeed. And you have to take great care to make sure like what you predict is robust enough. Whereas like compared to the other deepfake detectors that maybe X or Facebook or Instagram want to deploy, which kind of is based only on the volume. So like one relative percentage increase in accuracy is going to capture much more, obviously, deep fakes on their kind of volume of millions than 1% lower. And we have like our priorities are slightly shifted, like not like fully to kind of saturate on accuracy at the expense of maybe explainability and uncertainty quantification, because like having the models you can trust is more important than having like the maximum
super interesting topic that I could talk to you about all day, to be honest. And I guess the question I've got, as the detection models become more advanced, and obviously the deepfakes becoming more advanced, are you finding that the detection models can keep up with how advanced some of the deepfakes are becoming? I know to the naked eye, it's next to impossible now, but and from a model's perspective, can we keep up, do you think?
Well, I think, as long as there's training data, you can kind of keep up. The question is like whether the models will at any point become that advanced to kind of be good at mimicking almost everything. And, it's an open question. I don't know, whether that is going to happen at all. At this point, it seems that there's still like a wide margin by differentiation between what's like generated and what is real. But I'm not sure what's going to happen in the future, to be honest.
Sorry, go.
No, I think we will have to come up with some sort of watermarking, or like BBC is also working on this C2PA content provenance a project together with Microsoft, Google, and Adobe, whereby like every piece of digital content in terms of video, audio, or imagery needs to have like a specific metadata with the full kind of lineage of where it's been produced, by what camera, and then how it's been augmented, and so on. And then there is a world, I guess, like there is the one version of our future in which like that becomes the standard. And if you see something online and if it doesn't have that kind of C2PA metadata, then you implicitly should trust it less in a way.
Nice. Okay. Well, yeah, great to know. I think that segues nicely into governance and responsible AI. It seems like a topic that you're super passionate about. I know at the BBC, you chair I hope I get this right, the Gen AI Design Authority. You lead partnerships with Oxford around misinformation, as you just mentioned.
Mhm.
I think defining responsible AI can be a challenge in itself sometimes, especially across the US and the UK. Where different companies, I think, is different. What do you interpret as? What do you use as your framework and principles to guide your responsible AI efforts when you're developing a model? How do you ensure that it's AI for good?
Oh, wow. Well, as I said at the beginning, our hands are very much tied now,
Mm,
and I think in the future, the hands of the engineers are going to be even more tied.
mm,
The even like if you kind of if you do what we are doing, basically augmentations of the model weights, but like in the post training stage, like you take an open source model and then you kind of adapt it and change it and so on. I don't know, like there's been a recent paper by Anthropic, I believe, last year, where they kind of investigated how much the world model and beliefs of a large language models can be augmented in a post-training stage. And it seems that is basically limited in a way. What they've done is like they came up with a series of documents that reflect a different worldview. So they take this base model and they take the series of documents that reflect a different worldview and they continue pre-training, and then they do what they usually do. And on the surface level, it seemed that the model has changed their beliefs and has different biases and has different worldview. But like if you kind of are persistent and keep prompting it, it seems that the model has just learned to fake these things. So I think, when it comes to responsible AI and, uh, when it comes to model build and the responsible AI, it should be kind of transferred to the model owners, either in the open source world or in the commercial world. And like more transparency should be requested, both in in terms of the training data, but also in the methodology used and the tests done before that has been deployed. Because there's really very little you can do after you have your base model, after someone has spend like tens or hundreds of millions of dollars on training, which is not something like any organization apart from big tech can afford themselves to do. Uh, so yes, obviously we do what we can. Um, we make sure that we evaluate very well on the use cases that are interesting to us, that are relevant to the BBC, and we try to do the due diligence. But as I said, what one can do as a third party almost is very limited there. Yeah.
Oh, and yeah, media organization. You kind of touched on it. Meta, if
Mhm.
they improve their deepfake detection by 1%, it's a
Well,
huge thing. But I guess if just one gets through, the
mhm.
BBC can have huge ramifications. Just with the spotlight it has in it. How
Yeah.
do you balance that innovation of pushing maybe a state of the art model to production to balancing the needs of an organization like
Mhm.
the BBC and you know, keeping trust with its user
Mhm.
base.
Yeah. I think the pressure to act quickly has increased significantly in the past 2 to 3 years for media and news organizations. And many of our peers have kind of jumped into this kind of onto this bandwagon and have started experimenting with various use cases and really kind of um, integrating them in their workflow or the way how they work and so on. So the BBC has a much, more risk-averse position, and it has always had. And sometimes we kind of pick up a lot of criticism why it is that we're so slow, we're not fast enough. But I think that is all with a good reason. And I think as you just pointed out, the risk is magnificent there. So we do try to give ourselves time to test not only the models from the technical viewpoint, but also what effect they will have on our audiences, how our audiences feel, how the creative industry feels about us using specific models and so on. So all of that has been done in the background in the past couple of years. And we now feel, and I think BBC now feels they are now ready to take on innovation and start kind of putting some of these use cases into production and talking more about them.
Nice. Okay. Well, yes, super interesting. Thanks for sharing that. Moving on to the kind of final two parts of the podcast, more leadership and culture focus. You've managed teams of 20 plus. What's your philosophy around leadership? And just to take it back to the earlier part of the podcast, do you think mathematics has helped shape your leadership style?
Well, I think, first of all, like leaders coming from like STEM disciplines are almost diametrically opposite in their leadership styles to people coming from humanities. And, obviously that was one big part of it. But, I think even more mathematics is even more like fundamental and abstract of all STEM disciplines. So if we want to go kind of back to that view, so I think math is pretty much like the individual sport in a way. You never see math papers with like more than two authors. Like 3 is plenty, and 4 is just like out there. Like you instantly know something is wrong there. Someone is on that paper who shouldn't have been, because it's like it's impossible to tackle such complex tasks with like big groups of people, because it like requires intense like thinking and very close collaboration. Whereas like in machine learning, like you have groups and teams of like, we've seen now Gemini 2.5 has like 3,247 authors. That's like, wow, mind blowing. Right?
Yeah.
So, obviously from that point of view, like there is a sense of extreme ownership in maths community. And that's what I've got by my training. And it's always like a point of, giving credit where the credit is due, but not giving credit where no credit is due. But yes, apart from that, having a really strong sense of ownership and trying to kind of promote that with my team, and trying to basically instill in them more intellectual curiosity, more independence, more bias for action. I think it is very important, empowering people on the ground to feel that they can, when given a task, explore freely, right? And yes, I don't think really there's much more to it in a way.
Okay. In terms of BBC is a very complex organization. There's lots of moving parts. Lots of different stakeholders, and then you throw AI innovation into the mix. How do you balance what you probably want to do, which is cutting edge research, with taking maybe stakeholders on that AI journey, because there'll be lots of leaders out there where the AI is potentially coming into the organization now, front and center, and you've probably already been on that journey with the BBC. Are there any tips you could pass on in terms of stakeholder management, in terms of taking them on that AI journey?
In terms of stakeholder management?
Yeah.
So like at the BBC, I've been like in the R&D department, which is like slightly different. By definition, our mandate is to look slightly kind of more in the future than your typical product organization would do. But I think, like one rule of thumb is like, and we're fortunate now that AI is so hyped up. So everyone's primed. Everyone wants to do something with AI. And I think and we're all given opportunity to kind of pitch and give our views. And I think when this can break down in kind of product organizations is if you come up, if like your pitch or your project is more geared towards your interests and your kind of scientific curiosity rather than actually solving the real business problem. And I think, in general, you can't go wrong with kind of trying to understand business more, trying to understand what they are coping with. But I think it's almost kind of the first time now in a very long time that there is an opportunity to co-develop, like the AI staff should definitely co-develop new feature ideas, new product ideas with the business and with the engineering, because a lot of what business typically would come up with are like the incremental features. And although that is like super important, it might not be like relevant in a year or so, because like the field is moving so quickly, and you almost must kind of take this kind of meta view to either develop like a suite to develop and build for the future, rather than kind of building very scattered features, AI-powered features across the board to kind of appease a set of different stakeholders. So I think, all of these organizations should kind of focus more on having a very solid AI strategy, but that doesn't focus on now, that it has like a focus that is a little bit further away in the future.
Yeah, and I can imagine that can be quite hard at the moment, because everyone wants an AI agent to do things for them, and it'll be interesting to see where we are in 6 months, because no one can really predict this stuff coming beyond.
But this is, I actually have to kind of jump in now, because the book, again, I'm going to say it and recommend it to your readers, The Art of Doing Science and Engineering. And it's been published in 1995, maybe, by Richard Hamming. And in it, he says, like, he almost has a thought exercise, and says, let's predict the world in 2020. And I have to say, he's been spot on. And he has been able to predict the future. Or, for example, I've recently watched like Steve Jobs talking about Google Maps in 1980 something, like in his interview. So like there are people, and let's not forget all the investment professionals whose daily job is to predict the future. Otherwise, they are not going to have their margins met. But there is a way how to approach this kind of prediction of the future, because our world is almost kind of rule-based, and these rules are not as complicated as like in machine learning models. So there is a way to extrapolate as long as you properly understand the fundamentals. And I think, organizations in particular should kind of employ their topmost AI talent to help them build that worldview of the future, and not rely on people with various, I would say, commercial interests who would, want to persuade you of a specific worldview because their bottom line, because of their valuation and whatnot. But I think there is a way how to reduce that uncertainty.
Interesting. Yeah, I think it comes back to the role of the chief AI officer. I think that's becoming more prominent. Cool. I think that segues onto the final part in terms of trends and AI that you're using it in your everyday life. We've kind of touched on a lot of this, so we won't go into too much detail. But is there a particular trend you're most excited to see moving forward?
So yes, I am. I am like super impressed by the work that people are doing in the space of reinforcement learning, open-endedness. Like, there's been a lot of critiques nowadays, like recently with on the transformer-based architectures, and there is a group of scientists who are looking into kind of building better representations for these large language models that are not like stochastic gradient descent based, and there is like a really active field of research there. So I'm kind of quite excited about that and seeing where that kind of goes in the future. So it's like a different way of machine learning, different way of learning that is kind of more that it requires much less data and kind of results in the representations that are kind of human-like, as opposed to something within traditional machine learning models.
Nice. Yeah, it's certainly something I'm seeing. I think you go back like 8 years ago, it was just kind of DeepMind working on RL and multi-agent theory, and it was very focused in research labs. But there's a lot of great startups in the UK that are moving away from even LLMs now and focusing on a more RL approach. So it's going to be a really exciting time. I think we're moving into kind of the next phase, which is people focusing on reinforcement learning. Do you use any out of interest? Do you use any AI tools in your everyday life to stay productive? I know people are using Claude for coding. People I know use ChatGPT for text and Perplexity for searching. Is there anything you use as a leader?
Yeah, absolutely, absolutely. Coding has definitely become, 2 orders of magnitude easier nowadays, which is great. You can kind of quickly prototype and quickly test out certain things. But it was obviously experimentation since the release of the first model, how they can be most beneficial to me. And what I found is like that these models are like people say, oh, it's great, we can use them for brainstorming. And when I hear like creatives thinking that way, like I just feel super sad because like these models cannot be and should not be used for brainstorming because like they always have this kind of almost kind of mean approach, like this kind of a very pedestrian way of doing things. And it's not even a problem, that they have such a very generic view of things. But the problem is if you, as an individual with your own worldview, are exposed to that before you have the opportunity to think on your own, your mind kind of gets polluted. And you cannot think anymore about the given problem in a way that you would normally think. So I think there is this kind of degradation of the personal creativity. So I would never use them for brainstorming. And the worst thing you can do, and I've been a witness of that on a few kind of in a few situations, if you're given like some kind of open-ended problem or some kind of task, you're supposed to kind of, let's say in interview settings or whatnot, and you see people like they all come up with the same presentations, same responses to the same question. This is just not okay. And I think people should course correct a little bit on that one. So yeah, definitely. But then also, when it comes to really frontier fields like topics. For example, I was just looking at something in uncertainty quantification, and it's such a messy field, I have to say. Like, it's very difficult to kind of pick up heads and tails and so on and so on. And on multiple occasions, I was like trying to use deep research, O3, like just to help me a little bit survey the field. And every time it would come up with a different worldview. And I found it that myself, finding only 2 authoritative voices could lead me to kind of open up like a puzzle pieces, like everything, like yes, to open up the field much better, much quicker than actually rely on that completely view of the language model that is based on only completely on the statistics, and it cannot recognize really quality. But what it's good in, like if you want to go into the field that is very well established, that is very well present on the internet, and that you don't know much about, then you just go and really have a good conversation and can kind of speed up your learning journey, tenfold, 100-fold. So that's what it's very good in. So, but I would be careful in brainstorming and actually kind of inquiring about the fields that are very much progressing or like very much in flux.
I was in London and met a CTO in my network, and we had a quite an interesting talk that will we start asking people, will companies start asking people for who are qualified pre ChatGPT, because he kind of alluded to everybody's coming up with the same ideas because the students are just prompting a chatbot and building ideas out from that, and he just said it. He's definitely seen it in people that they're interviewing. So be super interesting to see how the market plays out there. And I can definitely encourage anyone looking for a job to kind of focus on the critical thinking, because I definitely agree. So that wraps it up. Danijela, thanks so much for coming on today. Really appreciate your time, sharing your knowledge, and all the very best to you in your new job as well in the next couple of months.
Thank you. Thank you, Chris. It's been such a pleasure.
Thank you.